Least squares regression from summary statistics. So there's actually a way to come up with the LSRL if you know some of the statistics about the data, like the mean of the x values, the mean of the y values, and a couple other things. So you don't actually need to just put the data in your calculator and have it calculate it for you that way if you know those actual values, if you know the summary statistics. So the first blank there, it says using technology is often the most convenient way to find the equation of the least squares regression line, but it's also possible to calculate the equation using only the means and standard deviations of the two variables and their correlation. So really convenient to use the calculator sometimes if you just have the list of data. But even if you don't have the list of data, you can still calculate the LSRL with just the means and standard deviations of the two variables, x and y, and their correlation. And then the note here, the least squares regression line always go through one specific point. You know one point for sure will be on that line, and that's the point x bar, y bar. So the mean of the x's and the mean of the y's. That's a coordinate point that will always be on the LSRL. It'll always go through that point. Using the track example as a reference, this would be like the mean sprint time, and that would be like the mean long jump distance. So as a coordinate point, that would be on the LSRL for sure. Okay, and then the definition here. How do we actually calculate the least squares regression line using those summary statistics? So we have data for an explanatory variable, that's the x, response variable y for n individuals, and then from the data we calculate the means and the standard deviation of the two variables and their correlation. Okay, so this is kind of really just summarizing what we just talked about here. So explanatory variables x, response variables y. N is kind of basic, that just always refers to how many people or how many subjects are in the sample or the experiment, what have you. Equation of a least squares regression line. Don't forget it's a hat on the y, so y hat equals a plus bx. So a is our y-intercept, b is our slope. That's the number on the x. So here's how you find these things. The slope, you can calculate b, the slope, if you have r, which is the correlation, notice the color code, and that's times this fraction right here, s sub y over s sub x. So that's the standard deviation of the y variable over the standard deviation of the x variable. And don't worry about like trying to calculate those individually. Those will be given to you, and you just have to show you could come up with the b value. Okay, so that's for the slope. And then if you want to get the y-intercept, that's a. That's the mean of the y values minus b, which is actually the slope of the line, times the mean of the x values. So you can get the slope and the y-intercept of the regression line just using this info right here. Not putting it in L1 and L2. So no data entry into the calculator even required. But that's assuming you know these special values. Okay, and the great thing about these formulas is you don't have to memorize them. So these two formulas actually are on the AP formula sheet that you get on our exams and the AP exam. They just look a little bit different. So the slope, for example, that's b sub 1 equals r, and then the fraction, standard deviation of y divided by standard deviation of x. So the only thing different there is they call it b sub 1. And then the y-intercept, instead of calling it a, they call that b sub 0. And then obviously the b sub 1, that means the slope. And why do they use that? Well, the equation of the LSRL, least squares regression line, on the formula sheet, remember that's b sub naught for the y-intercept, or not b, you could call it b naught or b sub 0. And then b sub 1 was the slope. So that's the reason behind why they call it that. Okay, so now let's actually take these and apply it to the example. So we're going to use feet to predict height. It says a random sample of 15 high school students was selected from the U.S. Census at School database. The foot length in centimeters and height in inches of each student in the sample were recorded. The mean and standard deviation of the foot lengths are x bar equals 24.76 and s sub x equals 2.71. Okay, so we got those values. The mean and standard deviation of the heights, we got y bar and s sub y. And then we have the correlation too. That's 0.697. So we're going to find the equation of the LSRL using only that information. So which one should we find first, the slope or the y-intercept? And in this case, like, you have to find the slope first because, well, for one, the slope formula depends. Well, the y-intercept formula depends on the slope. Like, you actually need the slope to calculate it. So we're going to find the slope and the y-intercept for this line. I also forgot my hat here. Let me add a little hat on my y. There we go. So the slope, let's calculate that first. So B equals, I need the correlation, R, and then times the standard deviation of y over the standard deviation of x. So we have those values, right in front of us. So in red there, correlation, 0.697, standard deviation of y, standard deviation of x. So calculate that, 2.75. And make sure you're showing these calculations for test credit and for AP exam credit. So you will have to just outline like what you plugged in. So that's part of your evidence. That's how you show your work. So now we got the slope. We just need the y-intercept. So the y-intercept, A, mean of the y's minus the slope times the mean of the x's. So we have all three of those variables now. Mean of the y's minus the slope times the mean of the x's. And you do have to outline this again. So to receive credit or full credit, you got to show your work there. And that equals 103.34. So last but not least, when I put this into my equation and I say y hat and x, I'll just replace whatever a and b are with their actual values that we found here. But let's say what y hat is. Let's say what x is. So we kind of have to define our variables and give it some context. So our result, we have the equation of the LSRL. Which one? The LSRL that predicts height, which is our y hat, based on foot length, which is our x. So that's our context. The equation of this LSRL is what? Hey, how's it going? AV guy just came in here and fixed my projector, so major thumbs up to him. Put the A value correctly, B value correctly, slope and y-intercept, and there's your line. That's it for these notes. I will see you in class.